Good afternoon. Everyone can hear me? Excellent. First off, thank you for coming to this presentation. Thank you for choosing me, the guy who does not speak French. This talk will be a fairly high-level overview of how we do stuff at Stack Overflow, how we actually make the site. So I've been with Stack Overflow for about 3 years on the Q&A team. That's the team that deals with the day-to-day of Stack Overflow, building it, bug fixing, deploying it, and our other 150 Q&A sites. So that's me having a good day at work. Don't remember, I might have brought Stack Overflow down that day. So I'm going to cover a few of our numbers, talk a little bit about how the team works, about our platform, what makes Stack Overflow, the hardware, the software underneath, a bit about scaling, and I'll conclude with a little bit about the cloud. So the numbers I'm going to show you are all from one day, only one day at Stack Overflow. The specific day is 9th of February of this year, so about 2.5 months ago. And here they are. 209 million requests came that day to our load balancers. 66 million of those were page loads. That's 1.2 terabytes of HTTP traffic that we sent out. That we got nearly 0.5 terabyte of incoming HTTP requests, or rather bytes received. Altogether, we sent out around 3 terabytes out. That's 500 million SQL queries were happening to make that happen. That's 5 billion Redis hits. 17 million Elastic searches, 3.5 million tag engine requests. And we render a question page on the server in 22 milliseconds. And our home page within 11 milliseconds. And the hardware we use 4 Microsoft SQL servers. For Stack Overflow, we have, they're divided into 2 groups, 2 for Stack Overflow and 2 for everything else. You can see that the Stack Overflow version has 385 gigs of memory and 2 12-core CPUs. The rest of the network has more because, again, it's not just Stack Overflow, it's 150 sites. Needs more memory for that. We're running off 9 web servers, that's it. The whole network, Stack Overflow and the rest of them, are running off 9 web servers, IIS web servers. We have 2 additional ones for staging. Those are for 2 sites on the network, only 2 sites that operate as our staging environment. I'll cover a little bit of that later on. And again, they have 64 gigs of memory each and 2 12-core CPUs. Only 2 Redis servers in a master-slave configuration. 3 tag engine servers. They are not just for tag engines. They use, that's where we also do our scheduling and other few things, just basic service boxes, because they have capacity. We have only one with 32 gigabytes because it needs to be upgraded. And only 3 Elasticsearch servers, fairly beefy machines as well. 4 HA proxy loaders, 2 networks, you'll notice they're Cisco hardware. The firewall is a Fortinet, and our routers are also Cisco's, because one of the things we do keep, at least with the networking layer, you want to keep to the same vendor. Network layers, if you start mixing up vendors, not so good things can happen. So those are our numbers. And what I'm going to talk about now is how we do things. is really what we found works for us. You know, we found out in an iterative process and came down to this way of working. It works for us, might not work for you, but hopefully you might learn something here to take with you some ways of working and building a team. We're everywhere. These are the 10 Q&A developers. So 3 of us are in the UK. I live in London. 1 is in Slovenia, another is in Mallorca, and 5 are all over the US, you know, east to west coast. So basically, we're a remote team, all of us. We have a program manager, a product manager, sorry, who is in Berlin, a designer, a few designers, one of them is here in France, community managers who live as far as Japan. So the company in general is across the globe. What that means is we need to keep everything online, all our communication. In order to do that, we use Google Docs a lot. Google Docs we use to write suggestions, internal suggestions, for example. We want to say, we call them RFCs, based on the IETF RFC formula. Basically, if someone has an idea about how to do something better, whether on one of our sites or internally, they will write a Google Doc and distribute it around. We use these as onboarding documents. We use these for interviewing. You know, if we do a code screening with someone, we'll write it in a Google Doc with them. And we'll share it out later on with the team, if needed. We use Trello a lot for coordinating work. So each project team, whenever you have a project, they'll normally have a Trello board, and they'll have cards for bugs, for features, for what needs to be done, for work in progress, and whatever's been finished. Stack Chat. Has anyone here used the Stack Overflow chat? Few hands, 3 or 4 hands. Yes, we have a chat. Hardly anyone knows that, but it's actually a friendlier place to ask open-ended questions and find out a bit more about whatever, how to ask questions, or whether a question you have will be well received or not. Worth visiting them. We have quite a lot of them. We use them internally. We have a bunch of internal rooms. The unique things about it are not so unique, I suppose now, is that it is a persistent chat. That means that for me in London, when I wake up, I go into the chat room and I check everything that happened that day or the day before. All my colleagues in the US, what they've been working on, what they've committed, what they've been talking about, discussions. So it gives me a continuity. I know exactly what happened before I, you know, as the start of my day. We also use Google Hangouts a lot to augment chat. Chat, as you all know, is a textual medium. So a lot of things get lost. You know, when someone says something, you don't really know how they meant it. Were they trying to argue? Were they being funny? Were they, you know, you don't get that in text. It's really difficult to convey. So one of the things we do very quickly, if you see that you're starting to disagree with someone or having a long discussion with them in chat, we always say, hop into Hangout. You know, do it face to face, talk to each other synchronously, and resolve it. A lot of the time, a 2-minute, 5-minute talk in Hangout will solve things. We also have our weekly team meetings in a Hangout. So all the developers with the manager, product manager, etc. We're all going to be sitting in one Hangout talking to each other. Last year we had a bit of a problem when we hit the 15 people in one Hangout limit. Thankfully, Google now upped that to 25, so we have some room to grow. One of the things we have in chat is a bunch of bots. These are just small programs that listen to input in the chat room and respond. So things that, for examples of what we do, when our continuous integration build is started, finished, if it has a failure, we'll get messaged about that in the chat room. So we're always informed about what's been pushed into the repo. When someone wants to build out to production, we get a chat message. We have things that check for, if there's a large amount of exceptions, there are automated system that will send a chat message. So we're aware of things and can immediately investigate. And we also have fun bots. We have the wheel of blame, which if someone basically writes in the chat room, "Not my fault," starts up with obnoxious music and a round, big round wheel that spins around and chooses someone at random. Or not at random. We believe in the power of the wheel to know. We have other fun things, like you can high-five someone, and we have a bot that will high-five them. Sometimes it's an interesting Reddit image to accompany. So again, it's things to bring a bit of spice into the working day. Otherwise, life is just way too boring. The basic tools that we use in the team, Visual Studio, Git, GitLab. GitLab, we have our own instance. We're not hosting it out. We chose GitLab over GitHub simply because one of the things we don't like as a company and as a team is to be reliant on a third party. If GitHub goes down and we can't develop and our CI can't pull, we're dead in the water. And that's not an acceptable risk for us. It's not something we're willing to have, so we're happy to host it, to manage it, to patch it, and have it under our control. TeamCity is our CI build. Whenever something commits, that's where it goes, automatically builds, pushes to our dev environment, so we can quickly test things. It is also our general deployment tool. This is what we'll use when we want to push stuff to our staging environment or to production. SQL Server Management Studio is where we normally write our SQL. The core platform, what I use every day, C#, ASP.NET MVC, IS, and Microsoft SQL Server. This is basically a Microsoft stack. A lot of people are surprised to hear that. Stack Overflow started that way, and it works really well, and there's no real reason for us to move away from it. Not just for moving for move's sake. But we're not just a Microsoft shop. So we run AJ Proxy, Redis, and Elasticsearch on CentOS, and our tag engine on Windows. Tag engine is an internal indexing tool. It is, as the name suggests, it deals with tags on questions. And basically, it's a way to query tags with a quick result. We used to do it with a bit of a hack in SQL Server using full text search, and outgrew that. That just didn't scale. So we decided to take it out into a service of its own. Again, if SQL is not good at something or you have a bottleneck, move it to a different server, to a different service, to something maybe specialized. Tag engine is a highly specialized piece of code. Actually, one of our team members is now working on replacing it with a new version and we're testing out on multi-core CPUs and possibly moving the whole thing to GPU. So those are interesting things that are happening with that. Some more tools. Stack Overflow performs really well. We wouldn't be able to render on the server a question page within 22 milliseconds if we didn't know where time was being spent. So we have things like Mini Profiler, which comes up in the browser. It is, hopefully I'll be able to show you later if the Wi-Fi here works well, what that looks like. But it gives us detailed numbers about how SQL was performing, how Redis was performing in the browser as developers. So whenever I go to a Stack Overflow page, I can see if it's being slow and why it's being slow. Observer is our dashboard. It will show things like CPU and memory for our SQL servers, for our web servers, and the different servers we have. And Grafana and Boson really work together. Grafana is, again, another dashboarding tool. It's an open source project. And Boson is, again, something we wrote inline as an alerting system. Boson is fairly unique in the DevOps world that I've seen, in that you can set up alerts and test them. So you can say, I want this alert to be set up, go over past data, and tell me when this would trigger. So this is a really good way of setting up alerts that don't give you false positives or false negatives. You can see exactly when something would have alerted you and why. And of course, adjust the alerting system and whatever query you put on it in order to ensure that you get exactly what you want. All of these tools, specifically Mini Profiler, Observer, and Boson, are open source. These are things we wrote in-house and are out there on GitHub. Feel free to take a look and maybe use them. As I said, we're not just a Microsoft house. We use the tools that work best. HAProxy and Elastic work best on Linux, so we're not going to run them on Windows, even though we do have Windows Server expertise in-house. So basically what happens when we build, as I said, the CI build, whenever someone pushes code, the CI builds notice it, TeamCity notices it, builds it out, publishes it to our dev environment. Then we have our staging build, what is written here as Meta. Meta stands for Meta Stack Overflow and Meta Stack Exchange, which are two of our Q&A sites that we use for talking about our sites. So Meta Stack Overflow is for something happened on Stack Overflow, you have a feature suggestion, you have a bug to report, it'll go there. Meta Stack Exchange is kind of a bigger version of that for the whole network. You think there's an issue that will affect everything in the network, or you want to change something, or talk about a feature request, or discuss something about how the whole platform works, that's where you can ask. Now, we built those two as our canary in the coal mine. Those are two sites that get a fair amount of traffic, not a huge amount, but enough traffic that if something is wrong or badly wrong, we will notice, and actually, more importantly, people will notice and will tell us. We have a very engaged community who are extremely responsive and are very quick to tell us when we screwed up, which is great. We even have I believe Boson has a Twitter alert. If Stack Overflow gets tweeted suddenly a lot, our operations team gets alerted about it, because Twitter tends to tell us very quickly if something is down. So those two builds go into the meta builds go into the two servers that I mentioned, the +2 web servers, and the production build goes to the 9 web servers. These servers serve everything that we have on the network. Stack Overflow, the other Q&A sites, careers, and all our main assets. So things that happen during the build, stuff that Team City will do. We do localization on JavaScript file, C# and Razor views. Some of these are done by actually plugging into the compiler and changing stuff. The syntax is just a rewrite of all of basically the whole code base to ensure it's localized properly. When I say localized, we have the main Stack Overflow, but we have Stack Overflow in 4 languages, in Japanese, Portuguese, Russian, and Spanish. So the UIs are completely localized, and if you speak any of those languages, you can definitely participate on those sites. After localization, we run a node service to minify, compile, minify less, and JavaScript, as well as bundling the JavaScript. And my last point here is about a rolling build. Why do we need 9 web servers? The idea here is that part of the build process will take web server 1 off rotation, so no one hits it, deploy to it, bring it back up, hit it once to warm it up, and then wait for a few seconds and do the same thing with server 2, 3, 4, 5, etc. This just keeps us online the whole time during the deploy. So a normal deploy will have 0 downtime. That's also why we have 2 web servers for the metas. This here is a snapshot of our op server. Things to notice is the CPUs there. We're highly efficient. Our SQL server CPUs run on at most double percentages. If a SQL server hits 20%, we start looking at why is it so hot? What's hitting the CPU so badly? Our web servers normally are on single-digit percentage usage of CPUs. And again, we have 9 of them. Why do we need 9 of them? Because we want to stay up during deployments. It gives us a lot of headroom to grow. Our traffic is very predictable, so we know more or less what's happening at any time of day. What I want to do now, if my Wi-Fi actually works, is see if I can show you a few things. This on the top right here is our mini profiler that I had a word about earlier. Now if I click it, you can see I have a little pop-up that tells me what is going on in how long things have taken, the SQL, how much time the SQL ran, how much time things happened in Redis. I can click through these, and you can see that I have things like the actual queries that have been run on the server. I'm told what the query is. I'm told exactly how long it ran, the cumulative time, and where in the code base it's been run from. So if I notice that the page is slow, I can immediately zero in on why. That really helps with performance tuning things. If you can't measure something, you can't fix it, you can't tune it. This is our live op server. This is what our, oops, sorry about that. But you can see the numbers there were not far off from what we have here. So doing this, we're running a website that a lot of other companies that have our scale of traffic will use tens and hundreds and sometimes thousands of servers. So how do we do this? Everyone in the team really knows SQL very well, so we write very optimized SQL. We understand the engine very well. We know how to index it. We know how to work with that. We know when to cache. We use fast libraries. Two of these, Dapper and Jill, are things, again, open source, that have been written in-house. Dapper is a micro ORM. It's a very, very, very thin layer. We basically write our SQL inline, and it just materializes the SQL into objects. That's all it does, and it's extremely fast at that. Jill is a JSON serialization library. Again, very fast. It uses a lot of metaprogramming and pre-compilation stuff. Both of these use a lot of IL emits and metaprogramming to achieve the speed that they do. We still have a few places in the code base that use things like link to SQL, and we are taking them out as fast as we can and wherever it's safe to do. We have some places that are just too involved right now to do that. But a large ORM that keeps track of changes and objects and all that has a performance penalty. Did I mention caching? Yes, we do a lot of caching. We have a few layers of cache, which we call level 1 and level 2. Level 1 is basically in memory on the web servers, and level 2 is Redis. So a server will basically go, do I have this in memory? Nope, okay. Redis, do you have it in memory? Nope, okay. And only then will it hit SQL or whatever other expensive item that needs to retrieve. We do focus on performance. Our founder, Jeff Atwood, has a blog post titled "Performance is a Feature." It's something that's very close to our heart, and we actually are very, very, very concerned with it. The team knows some of our team members, we jokingly say think in IL, so it feels like that sometimes. I gave the example of Tag Engine, said SQL doesn't work well, so we offloaded it to Tag Engine. Knowing when to do that is very important, to realize what the bottlenecks. And again, how do you know where you have your bottlenecks? You measure. So you have to keep measuring. Right. So a bit about why, one of the things you didn't see there is cloud. We don't use cloud services for anything really. Nothing internally. And there are reasons for that. We actually found that it is more expensive for us. We've done the cost-benefit analysis, which is something you have to do for your own. Maybe cloud makes sense for you. To us, it didn't. When I say it's unfit for our high-performance requirement and the tight control of it, the fact is you're renting someone else's servers, and they are being rented to you and to other people. So if someone else suddenly has a spike in their requirement, you may suffer from it. Our team also is highly familiar with cloud platforms. A lot of people, some of the people that we have worked in previous jobs on these platforms, and they're very well aware of their characteristics and how and where they excel and where they don't. One of the issues that we found is the network jitter. So internally within a data center, within a cloud, you ping between servers and you just never know how long it's going to take. For us, that is not acceptable, which is again one of the reasons why we host our own things. Things like latency and network jitter are one of the things. Again, we have a massive amount of headroom, as you saw from the SQL Server and web server statistics, that the cloud wouldn't quite match. Not in immediate responses. We'd have to start provisioning more things. These take maybe minutes, but they do take time. But one of the major reasons why we can't easily move to the cloud is simply size. Azure Cloud has SQL on it, but the largest database size that they support is 1 terabyte. Unfortunately, the Stack Overflow database is more than that. We'd need to re-architect the whole thing, break it up, figure out how to do that. And that is a cost that we're not willing to make right now. You can find a lot of details on these in an ongoing blog series by my colleague Nick Craver. He's written extensively about the architecture and the hardware that we use. I used a lot of the numbers that he provided in my talk here. He's still writing about it. He has, I don't know, 50 more blog posts in the queue. Highly suggest, if you're interested in how we do stuff at Stack Overflow, this is something to follow. So we have plenty of time for questions. The slides are on that link. And there are links to a lot of things in them. Everything in blue is a link. So.
Okay, if you only have one single, let's say, your own data center to serve, are you serving the traffic throughout the whole world with a single, with your own in-house data center or something like that, or you have localization and multiple sites for that?
We do use CDNs for our static content, but we don't really cache a lot of things that are generated dynamically. But to answer your question, yes, we are serving globally from one data center. For disaster recovery, we actually have a second data center, which is built up as closely as possible to the first, barring hardware that's no longer available and things like that. But basically, yeah, that is just a failover. If something goes wrong in our New York data center, we will fail over to the Colorado one.
Okay, and the two servers, SQL servers, are in multi-master replication mode?
Essentially, yeah. So we have a read-write and we have a read-only replica in one availability group. The availability group also includes servers that are in the other data center, but they're sent to it via log shipping, just to keep it up to date. So one of the things we do in the code base, for certain queries where we know we don't need to have up-to-date data, and where the data is we don't need to write, we will query the read-only data to reduce contention on the read-write master. Anyone else?
Can you tell us how do you detect large amount of unusual exceptions, please?
We have an exception log. We log everything into SQL. And our alerting systems basically look for those numbers. And they'll know, we had 3 exceptions in the last minute. Ooh, we had 2,000 exceptions in the last minute. Okay, alert. We get alerts in emails. The SRE team, SRE stands for Site Reliability Engineering. They'll have someone on call that will get alerted about it. And as I've said, we also have the chat rooms that we keep an eye on.
How do you handle high availability with only 2 Redis nodes?
Redis, we don't use Redis for persistence. It's purely for caching. So we could run without Redis. We would really, really, really prefer not to, but we could. Things that are happening now with Redis is Redis cluster, which is something that is happening, and we're absolutely going to take advantage of it. It's something we're looking forward to very much.
How many bugs do you have in your bug database?
A lot. We don't have a debugs database. We have meta sites. Whenever someone tags something with bug, we use an internal page that queries our tag engine, basically to say, on all the meta sites, give me everything that is tagged with bug, and that has not been status completed or status declined or whatever. I don't have an exact number. Last I looked, we had something like 1,700 open bugs from the last year. But these are open bugs that haven't been triaged properly. It could mean anything from bugs that are not valid anymore because they're old, or something that has been tagged as bug B, but actually is just a misunderstanding of how things are. But we do look at them. The community team definitely looks at those and sends them to developers to fix. We have people on bug duty. So every week, someone in the team is exclusively on bug duty. That is what they do, fix bugs.
Excuse me. Given that the .NET Core will be supported on Linux, are you considering moving platform to save costs? Maybe?
We will never rule it out. It's a very exciting thing that is happening now, in the same way that SQL Server is possibly going to go on Linux. What we're going to do with that, as we do with everything, is we're going to test the hell out of it before we actually commit to anything. If it has benefits, if it actually works better, absolutely. If it doesn't, then absolutely not. But there's no reason to think one way or another right now. Things are still so early. I can tell you that we have a few team members that with their open source projects, they are absolutely porting them to .NET Core right now. I think Dapper has already done that. So we're actually gaining expertise with that within the team. Thank you. Any more questions?
How many times did it take you to have a 20 millisecond average load time on the page? Because I imagine it's a very low number, and you must have put a lot of effort to get to that number. So,
how long? 8 years?
yeah. So at start,
You don't stop.
Yeah.
Performance work. There's a few things you need to do. I said measure, 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 but you also have to have kind of a level of you saying, I'm happy with this, or this is good enough. But if you keep doing it and keep doing it and keep doing it, and you keep measuring and you keep finding out the new bottleneck, because you fix a bottleneck, you know what happens? Something else becomes the bottleneck. That wasn't a bottleneck, but it will be a bottleneck that is that much higher. You do it for 8 years, you do a little bit every year, and you get that performance. This isn't unique to C# or SQL Server. This is true for any platform. You could write performant websites in Ruby and whatever, you know, and if you really wanted to, I guess, file-based storage. But again, no one writes that because we have tools that actually make it a lot better and easier.
You talk about bottlenecks. Which is your current bottleneck at the moment? What's the next step?
That's a good question. One of the things I mentioned was tag server. It's actually right now, it's been written originally about 3 years ago. It does a lot of crazy things that it was designed to do, and that now some of them are not really needed. So we are, like I said, we're in the process of rewriting that. We saw in our current iteration of it, which is not fully featured, it's more of a proof of concept. We saw an improvement in like 2 orders of magnitude in certain queries to it. So instead of something taking 100 milliseconds, which for us is a long time, it takes 1 millisecond. And a lot of things that were a few milliseconds, they don't even show up. So that's work in progress. Whether it'll work on a GPU or on multi-core is one of the things we're trying to test. We're, again, doing a cost-benefit analysis of both approaches. We're going to run these things on test hardware to see how they work, each of them, and we'll decide which approach to take. One second.
Okay, I have 2 questions. First one, today lots of companies are migrating from SQL to non-SQL databases. And since you test everything, have you tested any non-SQL database, and are you considering migrating, or what are your views on that topic?
Short answer is we're not going to say no to anything if it proves itself. Again, Redis is NoSQL. You can think of it that way. We do use it. But the fact is we have a huge investment in SQL Server. And ripping that all out and replacing it is hugely costly. So it's not really on our horizon. It's not something we're going to test. We did try for some other internal systems. We played around with Cassandra until it blew up. We lost all the data on it. We just couldn't continue with it. So we ended up dropping it. Again, for very large amounts of data. But again, people ran it and tested it locally, and it failed for us. Things that we also have to consider beyond just development for a platform, like a database platform or a persistence platform, are things like how does it integrate with our alerting? How does it integrate with operations? How does it talk to other things? Does it need to talk to a SQL database? Can it even talk to a SQL database? Do we need to write software for that? A lot of these NoSQL, the new ones, are just not mature. You know, there's a lot of systems out there that don't even have the minimum in security. You know, that rules them out immediately for a lot of things, if that answers the question.
My second question is, why do you use Elasticsearch for?
To power our internal search. We have search for the Q&A sites or posts. There are a few specialized queries that you just can't do on Google. So if something is an answer, if you want to search for just answers that have more than 5 upvotes in specific tags, so you know you'd need Elastic for that. We also use it for search within our chat rooms and within our careers jobs profile thing.
Thank you.
Thank you.
Thank you very much.
Okay, I guess we're out of time. I will be around today and tomorrow, so if you have more questions, want to chat, come see me. Okay, thank you.